Hello friends, myself Hardik Patel from LJ Institute of Engineering and Technology. Up to last session, we have seen the basic concepts of multiple integrals and application of multiple integrals and triple integration in a cylindrical coordinate system. In today's section, we are going to continue the triple integration and the volume by double integration. So, first of all, the triple integration in a spherical coordinate system. Now, spherical coordinate system is in a form of r, theta and phi. Okay. Now, see why we are considering it as a spherical coordinate, because these are going to be whatever the supposition we are going to take out, they are going to be satisfied the equation of sphere, and center is going to be a 0, 0, 0. Now, the relation between Cartesian and the spherical coordinate system is given as x is equal to r sine theta cos phi, y is equal to r sine theta sin phi, and z is equal to r cos theta. Then your triple integration f of x, y, z, dx, dy, dz is reducing in the form of triple integration f of r sine theta cos phi, r sine theta sin phi, r cos theta into mod j dr d theta d phi. Okay. Here the region remains as it is, no change in the region. If the volume is V here, then here also it is remains V. And J is nothing but it is the Jacobian of x, y, z with respect to r, theta and phi. And if you are going to find the Jacobian of this, then it is going to be a r square sine theta. So your triple integration is reducing in the form of triple integration f of x, y, z, dx, dy, dz over a volume V is triple integration over a volume V f of r sine theta cos phi, r sine theta sin phi, and r cos theta, r square into mod j is replaced with r square sine theta dr d theta d phi. Okay. Now, first of all, in a spherical coordinate system, if you have given any curve, then if you have given any curve and if you are going to reduce it in a form of spherical coordinate system, then you have to start with the origin. See, here we are starting with the example. This is the evaluate integration 0 to infinity, 0 to infinity, 0 to infinity dx, dy, dz upon 1 plus x square plus y square plus z square the whole square. Correct? Now, if you are going to integrate this directly with respect to x or y or z, then this function is not directly integrable. So, what we are going to do is, we are going to reduce this in a form of spherical coordinate. So, x is equal to r sine theta cos phi, y is equal to r sine theta sin phi, and z is equal to r cos theta. Now, changing into the spherical coordinate, so you will have the first octant. See, this is your first octant because x has a limit from O to infinite, y has a limit from O to infinity, and z also has a limit from O to infinity. That means you have the first octant. This first octant region is there. Okay, all terms are x, y, and z. Three of all are positive. Now see, first of all, we are concerned with the limits of r, theta, and phi. Now r is a radius vector which is starting from 0, 0, 0. That means O, and it is going to end on a curve. Now here there is no curve, so r is starting with 0 and it is going to end when r is equal to infinity. So this is the radius vector because there is no surface which is going to bound this region, first octant. Theta, now theta is nothing but theta is the angle with a positive z axis. That means whatever the z axis we have positive z axis, the angle with that is called a theta. Okay. Now, if you are going to check out the angle theta, then you have this radius vector is either starting with xy plane and it is going to maximum z axis. That means if you are going to write down the limits of theta, then it will be starting from 0 xy plane. That means it is 0 and it is going to end onto the, because see your radius vector is starting with a 0, 0, 0. That means xy plane. In xy plane, if you are going to consider, then the angle is going to be 0. Sorry, angle is going to be 90. And it is starting from z axis. So if you are going with z axis, then it is at a z axis it has an angle 0 and at xy plane it has an angle 90. So theta is varies from 0 to 90 in xy plane. Okay. And the angle phi is nothing but angle of a projection of a vector. That means if you are going to take this projection of this radius vector, then whatever the projection you have, that projection has an angle with positive x-axis is called phi. The angle with a positive x-axis is called phi. So this phi is going to be moved from positive x-axis to positive y-axis. So this phi is going to be moved from theta is phi is equal to 0 to phi is equal to pi by 2. Okay. Please remember this phi is an angle in a xy plane. Okay, in xy plane you have to take the projection vector of a radius r, and whatever the projection vector you have, that it has an angle with a positive x-axis. That angle is called a phi. Okay, so if you are going to put the limits, then r is starting with a 0 and it is ending to phi. Theta is starting with a 0 ending to pi by 2, and phi is starting with a 0 ending to pi by 2. Correct? So your integration is going to be in a spherical form. Integration 0 to infinity, 0 to infinity, 0 to infinity dx, dy, dz upon 1 plus x square plus y square plus z square the whole square. It is going to be a from r is from 0 to infinity, theta is from 0 to pi by 2, and phi is also from 0 to pi by 2, r square sine theta dr d theta d phi, because mode j is r square sine theta and dx dy dz will be replaced with new coordinates r theta and phi. So and in denominator you have x square plus y square plus z square, but x square plus y square plus z square is going to be a r square. If you are going to substitute the value of x, y, z, then you will have r square. Now this form is a variable separable form. So separate the integration of r, separate the integration of theta, separate the integration of phi. So you will have integration from 0 to pi by 2 r square upon 1 plus r square the whole square dr into 0 to pi by 2 sine theta d theta into 0 to pi by 2 d phi. And if the first integration is not directly possible, so we are going to put r is equal to tan theta or tan t. So dr is equal to sec square t dt. So your integration is going to be r is 0, then tan t is 0, that means t is 0. And r is infinity, then tan t is infinity, that means t is pi by 2. So integration is first integration is reducing in the form of 0 to pi by 2 r square, that is tan square, upon 1 plus tan square, that is sec square, the whole square is sec raised to 4, and dt will be sec square t dt. Okay, so sec square cancel out one time and you will have sec squared in denominator. These two integrations remains as it is. Now tan square is sin square upon cos square. So sec square cancel out, and 1 sec square into cos square, that will be a 1. So you will have a sin square. Integration from 0 to pi by 2 sin square t dt. Sin has an integration minus cos, limit is from 0 to pi by 2, and d phi has an integration phi, limit is from 0 to pi by 2. So sin square is not directly integrable, so replace it with 1 minus cos 2t by 2 and integrate it. So that will give you t minus sin 2t by 2. And here, if you are going to substitute the limit, then minus cos pi by 2 plus cos 0 into pi by 2 minus 0. Cos pi by 2 has a value 0, cos 0 has a value 1, so you have pi by 2. So this will give you 1 by 2. If you are going to substitute the limit, then t is pi by 2, then sin pi is 0. And if you are going to put 0, then this both terms are going to be 0. So you will have 1 by 2 into this bracket is going to be pi by 2 and this pi by 2. So the final answer is going to be pi squared by 8. Okay, so please remember that if you are considering the spherical coordinate, then in that case you have to consider that whatever the r is a radius vector from origin to the curve in 3-dimensional surface. Okay, secondly, theta is the angle with a positive z axis, that means this is z axis, then you have to consider theta from z is equal to 0 to wherever your curve is going to be or region is going to be end out. And third one, phi is nothing but it is a angle with a positive x-axis of a projection of a radius vector. That means in xy plane, if this is the x-axis, then the angle with this positive x-axis is called the phi. Okay, and it is the angle of a projection. Now we are going to find the volume by double integration. Now, if you are finding the volume by double integration, then if suppose z is equal to f of x comma y is a continuous surface on a region capital R, and f of x comma y is greater or equal to 0 for all xy in a region capital R, then double integration f of xy dA is called the volume of the solid region between the curve z is equal to f of xy and in xy plane. That means suppose here you have a xy plane and here you have a surface, here you have a region something in xy plane, then from this xy plane to the whatever the surface you have, that volume is going to be obtained by this double integration. Okay. So double integration R f of x comma y dx dy or dy dx is your it is your volume in 3 dimension. Now the formula of volume in a Cartesian coordinate system is written in a form of double integration z dx dy. Okay. So instead of f of x comma y, you can write down this as a z. That means in that case you have to find out the value of z from the given of surface. Okay. Okay. Suppose you are writing this in a polar coordinate system, then the volume is given by v is equal to double integration z into r dr d theta, because dx dy is going to be a r dr d theta. Done. Find the volume bounded by the cylinder x square plus y square is equal to 4 and the plane y plus z is equal to 4 and z is equal to 0. Now see, if you are starting with a solution, then first you have to put the limits of z. Now this is the region of cylinder. See, x square plus y square is equal to 4. In a 2 dimension, it is a circle like this. And if you are going to extend that circle in 3rd dimension z, then it is going to be a cylinder like this. Here what we have. Now you are going, suppose this is the cylinder, you have x square plus y square is equal to 4. And you are going to cut it with a plane x y plus z is equal to 4. That means it is like this. Y plus z is equal to 4 plane. Okay. So you are going to cut it transversely. So it is the volume you have is like this. This is the volume which we have to find out. Okay. So lower surface is the z is equal to 0 surface. Upper surface is nothing but it is a plane. That means you have plane y plus z. This plane by which we have cut out, it is nothing. That plane is your y plus z is equal to 4 plane. So if you are going to find the limits of z, then z is starting with 0. And from this equation, you have z is equal to 4 minus y. Correct? So this is the first thing what you have to find out. Secondly, you have to find out the projection. So once you have cut the cylinder, and if you are going to find the top view, then top view is nothing but it is going to be a circle in 2 dimension. Correct? So you have a whole circle in 2 dimension. So we have to find out the wall area of this. Correct? And you have to integrate over this area. X square plus y square is equal to 4. So what we are going to do is, so volume V is going to be a double integration over R Z dx dy. Now you have two surface. In that case, you have to write down Z1 minus Z2. That means upper surface minus lower surface. Your upper surface is Z is equal to 4 minus y and lower surface is Z is equal to 0. So 4 minus y minus 0. So your integration is going to be in double integration 4 minus y in dx dy. Correct? Now see, as the top view of the cutted cylinder is nothing but it is a circle. X square plus y square is equal to 4. So we are going to reduce this in a form of polar coordinate because it is easy to integrate. So we are going to put x is equal to r cos theta, y is equal to r sin theta, and that will give you dx dy is equal to r dr d theta. Correct? And you have x square plus y square is equal to r square. So if you are going to put the limits of circle x square plus y square is equal to 4, then you will have r is equal to 2 because r square is equal to 4, that will give r is equal to 2. So your r is starting with a 0 and it is going to be end on 2. And the whole circle is there because we have a whole circle as a projection. So whole circle is there. So theta is starting with 0 and it is going to end on 2 pi. So theta is starting with 0 ending to 2 pi. R is starting with 0 ending to circle r is equal to 2. Okay. So if you are going to put all the limits in double integration, then double integration V is going to be a double integration from 0 to 2 pi, 0 to 2, 4 minus y is equal to r sine theta. Okay, here we have to write r. So y is equal to r sine theta into dx dy will be replaced with r dr d theta. Correct? Now first I multiply r inside, that will give you integration from 0 to 2 pi, 0 to 2, 4r in minus r square sine theta, integrating with respect to r. So you will have 4r square by 2 minus r cube by 3 into sine theta. Limit is from 0 to 2. Now first put the limit. So 2 is a 4, 4 16 by 2, that will be 8 minus 8 by 3. And if you are going to put 0, then both terms are going to be 0. So we have the integration, v is equal to integration from 0 to 2 pi, 8 minus 8 by 3 sine theta d theta. Integration of 8 is 8 theta and sine as a integration minus cos. So you will have plus 8 by 3 cos theta. Now limit is from 0 to 2 pi. If you are going to substitute 2 pi, then you will have 8 into 2 pi, that will be 16 pi. Cos 2 pi has a value 1 minus 0 minus cos 0 has a value 1. So 8 by 3 will be cancelled out and the answer you have is 16 pi. So the volume in between these two surfaces and interior part of a cylinder is 16 pi. Okay. These are the topics which we have covered in today's session. If you have any doubt or any query regarding these topics, then please feel free to contact me. Thank you so much.